Hello, welcome to Simplifying Rational Functions with Complex Fractions for NTI. This is going to be the last lesson on rational functions, and we're going to simplify just 6 equations here. And the first one is split up, and I've copied it so that we can look at 2 different ways to simplify it. So the first way is finding the least common denominator between these 2 fractions. So there's a fraction in the numerator with a 3 in its denominator, and then if we look at this complex fraction, we can see that the fraction in the denominator of it has a 2 in its denominator. So the least common denominator between those two is 6. We'll just multiply them together. So that means we'll multiply the numerator and the denominator by 6 to start this one. Now I'm going to pause that one and then look at a different way to simplify this fraction. So the other way to do it is just to multiply by the reciprocal. And this will be alright for something as simple as this one, but it could get pretty nasty looking when we have binomials. Reciprocal, I spelled it right. So we want to look at both ways right now, and I think you'll see my point once we get over to binomials. But anyway, I've started that one already, and we'll carry that one out. So we'll do that first before we look back at the least common denominator way to solve this same question. So multiplying by the reciprocal, I have -5/3 times -2/1 after doing that, and I actually want to start solving this by working down. So I'll be multiplying -5, -2, and 3 times 1. So that one's easy enough. And then with the least common denominator, we are going to distribute 6 to the numerator of the fraction in that numerator. So I've got -30 divided by 3, and then 6 times -1/2. And these are easily simplified now, which is -10. So we'll just simplify them separately in the numerator and the denominator to get -10 over -3, which is the same answer as what we got by multiplying by the reciprocal. So clearly this is working out a little bit more with a little bit more steps if we work with the least common denominator, but again, we'll see how this changes once a binomial is introduced. Alright, so here's our second example. And our second example has addition in the numerator and addition in the denominator. And I'm just going to say this is multiplying by the reciprocal. I'll abbreviate some words here. And so with this first method, by finding a least common denominator, we're going to take the least common denominator between 3, 4, and 2 and multiply that in as 12 over 12. Right, so you can find the prime number between each of these and just multiply them all together. So I just multiplied 3, 2, and 2 together to get 12. And I'm going to put in these fractions here because what we're going to be doing is distributing this 12. So I've got 12 over 3 plus 60. And then 36 over 4 plus 6. Now, this isn't so great looking, but you can see the simple operations we can do now. Because we chose 12, we can divide 12 by 3 and 36 by 4 in this other complex fraction. So our function will end up looking like 4 plus 60 over 9 plus 6, which now we can do some simple addition and get 64 over 15, which can't be simplified further. Yay, there we go. I don't actually know why I chose to include, there's not a variable in this, so we don't need this f of x here. But there we go, 64 over 15 is what that fraction simplifies to be. Now, I'm going to do the same thing. I'm going to pause, you can pause the video, and I'm just going to work the same problem just by multiplying by the reciprocal. And there might be a little bit more work there. Right, so I got the same answer by multiplying by the reciprocal, no surprise there. And it does seem simpler. So the purple way was with the least common denominator. That's really us just practicing what it looks like. Multiplying by the reciprocal is what I'm sure a lot of you all have heard and what's been taught before. So we're going to look at number 3 here, where we actually have some variables, and I do need to write f of x. So if we look at what do we need to make our least, or what do we need to notice as our least common denominator, that is going to be 12 again. So I've got 3, 2, and 2. So I'll multiply by 12 over 12. And again, I'm going to work down. So I'll have 12x over 3 divided by 12x over 4 plus 12x over 2. Now, if we were going to multiply by the reciprocal, we would have to do an extra step in here, which is add these fractions together. And typically, we kind of want to avoid adding when it comes to fractions, because that does involve making sure you have given one fraction enough so that it can have a common denominator between the other fraction. So we try to avoid that. So that's the whole point of me showing you that we need a least common denominator. So anyway, carrying on here, we can actually work with all of these fractions individually and then see how they can be simplified once we have divided them. So I'll have 4x in the numerator and 3x plus 6x. Now this is super easy to do. We'll have 4x over 9x, and the result will be 4/9. So that's what f of x equals. So it's pretty simple linear function, horizontal line there as a result. That's all that big old complex fraction boiled down to be. Alright, last example here, and then I'm going to set you guys off. So number 4 has binomials in it, and it's going to work similarly to how we noticed there was a and I can break this up. 4 is 2 times 2, right? So we know that there's a 2 in common between these two fractions, and there's no 3 in common between 4 obviously and 2, but we'll use that 3 and both of those 2's to find the least common denominator, which ended up being 12. So if we can notice what the least common denominator is in these binomials, then we can essentially do the same thing. And to do that, we are going to have to factor some. So what can be factored, so this denominator right here ought to be factored. And then we can start using this idea of a least common denominator. So I'm just going to factor what I can. Factor out an x. And then I see that I've got an x plus 5 in common between both of these fractions. So I seem to have an x plus 5 and an x minus 4 in common. So that is the LCD that I'll be multiplying by. And I can leave, you don't have to multiply it out, I can leave it in the factored form. And then distribute this numerator to each fraction in the numerator, and then this denominator to the fraction's numerator that's in the denominator. Visually, this makes sense. Hopefully you're just not listening to this, because it's pretty confusing if you're not looking at what I'm saying. So I'm going to go ahead and multiply those things out. So I've got x plus 5, and you'll probably get to a point where you don't need to show everything here, but I'm going to do that. So I'm going to color code it as well, so you can see where these blue factors are being distributed to. And it's going to look like you need some space. That's why you have a lot of space on this page. So if you're doing this in your notebook, hopefully you've left some space. There we go. And then we got the denominator to do. Which is going to look like this. Alright, and at this point we can divide out what's in common between the numerator and the denominator. So I'll have my x plus 5's divide away, x minus 4's divide away, and x plus 5's divide away down here. Now, I have forgotten to include this x as a part of that least common denominator, but I can go back and add that in. Not a problem, not a problem. And I know I did that incorrectly because I didn't get everything to divide away. So now that I have, and by everything I mean, now that I have all these denominators divide away, I don't have a crazy complex fraction anymore. I just have a bunch of polynomials, well, a single polynomial in my numerator and then a polynomial in my denominator. So I'll end up with x minus 4 times x plus 3 times x plus 5 times x all over x minus 4. So what did not divide away was what I've highlighted here in yellow, and that's what I've recopied down below. And then just to wrap this one up, I've got to multiply and combine like terms, and I'll just do that real quick. So I'll have my 4x squared and then plus 11x. There we go. Alright. Got it. First try. Yep. There it is. Okay. So there you have it. That is going to be the most complicated problem you'd see about these complex fractions. I would like you to try these two that are on the back of your page. I'm I'm going to show you the answer to them on this notes, so if you pause it and stick around, then you'll get to see how that's worked out. Thanks for watching. Bye. So here's the last bit of the video. You can see how I've distributed the least common denominator, and I did have a constant that was a least common denominator, so I did do that. And then there's the answer for number 5 there. And then number 6 has the answer there for, and it was quite a little bit to simplify. So making sure you have divided out that least common denominator after distributing it, and then combining like terms in the numerator, you'll be able to get that polynomial that I have, that cubic. And that's all. Thanks for watching.